Alright, now welcome to solving equations by factoring polynomials. So we just spent a lot of time and effort solving, or not solving, but factoring polynomials. So factoring is the act of taking a polynomial and just breaking it down into a product of two other polynomials. Typically there's two binomials involved. Sometimes you have just a greatest common factor and a binomial or a trinomial. And so we spent a lot of time essentially dividing and breaking a polynomial into two products or two factors of a product. So now we're going to use all that information that we've learned to help solve problems. And so what I want to know is what value of x will satisfy this equation so that both sides are equal. Now the hint for all of these is try to get one side equal to 0, because typically when I factor and get two things that multiply to be 0, either that thing has to be 0 or the other thing has to be 0. Now, this thing we could factor the greatest common factor, but it wouldn't be set equal to 0. So the first thing you must do in these problems is just make sure at least one of the sides, or probably just one of the sides, is equal to 0. So I'm going to subtract 10 from both sides. Now notice the x squared and the negative 3x remain the same because negative 10 does not have an x. It's not a like term. So now I have this expression that says that x squared minus 3x minus 10 has to equal 0. So now what I'm going to do is I'm going to factor. And I know that I have the product of negative 10 in the last term and a product of x squared in the first term. So now I have to have x and x to get the x squared product. And it's because this is a negative number, I know I'm going to need a plus and a minus. I'm not sure which one's going to work. I'm using the guess and check method. I need factors of negative 10 that add to be negative 3. Looks like I need a positive 2 and a negative 5. And before I start the next part of this problem, let's just double check for a moment that I factored correctly. The inner product is positive 2x. The outer product here is negative 5x. That will combine to make negative 3x. Check the first. X times x is x squared. Last times last is negative 10. Okay, so we know that we factored correctly. Now again, this idea, and this is super important, this is called the zero product property. And that means that if you have a product of two things that equals 0, then either one factor or the other or both are equal to 0. And I wrote product twice there. I meant to write property. Zero product property. Okay, so by that logic, because I have two factors, x plus 2 and a second factor, I'll use a different color here, x minus 5, and I'm multiplying those two factors to get 0, then either x plus 2 is 0 or x minus 5 is 0. Let's begin by assuming the first one. X plus 2 has to equal 0. Alright, I took the first factor and just set it equal to 0. This is pretty easy to solve. Subtract 2 from both sides, so x has to be negative 2, and that could be an answer to this. So let's plug negative 2 into this function. I'm going to have negative 2 squared minus 3 times negative 2, and I want to see if that equals 10. Negative 2 squared is 4. Negative 3 times negative 2 is positive 6. 4 plus 6 is 10. So I know that that solution works. That's what we're doing here, is we're finding the value of x that will make this equation true. Now down here, it's either going to be one or the other. It can't be both negative 2 and something else. So I have an or in between. Or x minus 5 has to equal 0. Solving this is also pretty easy by adding 5 to both sides. And so x has to equal 5. So your answers to these questions of what x has to be to make these quadratic equations true, you should get two answers, one answer, which is technically 2, we'll talk about that later, or no solution, no real solution. So, these are the two values of x, 5 and negative 2, that would make this true. 5 squared is 25, minus 15 is 10. That works. Okay. I'm going to go a little bit faster with the other ones here. Now we got the idea is that I'm trying to factor and set each factor equal to 0. So remember our factoring algorithm. I first look for greatest common factor. Do I have one in this problem? I do. It is 2. So I'm going to take a 2 out of everything. And I have 2 times, and it's going to be 3x squared minus 5x minus 2. Okay. And now I need to guess and check. Don't forget to keep that 2 along the ride here. That 2 comes down and everything. I know I have 3x and 2. That's nice because it's prime, so I know it has to be a 3x and it has to be an x there. Now for the 2, it has to be negative 2, so we have a plus or minus 2 or plus or minus 1. So I'm going to do a plus 1 and a minus 2 and see if that works. Alright, I have 1x here, and I have minus 6x. Does that combine to be the negative 5x? In this case, it does. Lucky first shot there. Check the first term, 3x squared. Check the last one, negative 2. Okay, we're in business. So that one works out. And now, again, by the zero product property, that's probably one of the most important ideas of this video, is if I have two factors, and in fact I have three this time, one, and then the second factor is here, and the third factor is here. I have three things that are multiplying together to equal 0. And if that's true, one or all of them have to be 0. Now let's look at the first factor, 2, that I pulled out from the very beginning. Can that be equal to 0? Well, it can't. Of course not. 2 is not 0. So I skip right to the blue one and say, can 3x plus 1 be the 0? Let's find out what x has to be to make that true. Subtract 1 to get 3x equals negative 1. I divide by 3, x equals negative 1/3. So that's one possibility for an answer. Or we check the green factor, x minus 2, and that might be the 0 that I'm multiplying together. And of course, x would equal 2. So you have two answers for this one, x equals negative 1/3 or x equals 2. All right, and again, we want one side to be equal to 0, so the first thing we're going to do for this next example is add the 25x to both sides. Okay, and when I do that, I get 10x squared plus 25x, I'm running in standard form, minus 90 equals 0. First thing I need to do is look for a greatest common factor. Do I have one? GCF. Okay, it looks like I do, probably 5. Let's take a 5 out, and I get, looks like 2x squared plus 5x. And 90 divided by 5 would be 18. So it's negative 18 equals 0. All right, so I took out a greatest common factor. Is this a special case? Before I start guessing and checking, I forgot to do that in the last one. I just kind of took it for granted that it wasn't a special case. And this one is not a special case either because there's no perfect squares in the first or the last spots. So then I just try to factor as normal. So I have 5 times. I'm trying to factor this trinomial, this quadratic trinomial, by guessing and checking. Lucky for us, the first spots have to be 2x and x because 2 is prime, and that's the only factorization of 2. Bad news for us is I have a couple options for 18. I know it's negative, so now I have to have a plus or minus. I'm not sure where the plus or minus is going to go. So we'll start with plus or minus here. Factors of 18, I could do 9 and 2. Let's see that one. So 9 and 2, I'm just going to put 9 in here and 2 in there. I get 9x. Oh my goodness, did it work out again? Looks like I got it, first try. It's like I made this flip chart or something. All right, so I have the factorization correct, I believe. 2x times x is 2x squared. Okay, that's that one. 9 times negative 2 is negative 18. All right, we have it. So that's good to go. Now I have the zero product property. Again, that is the zero product property, which states that if I have a bunch of things multiplying together to get 0, then one of these factors has to be 0. It either has to be the 5 up front, has to be the 2x plus 9, or it has to be the x minus 2 here. So if x minus 2 is the 0, then x would have to be 2. That's one possible solution. Another possible solution is that 2x or 2x plus 9 has to equal 0. I'm getting kind of squished in space here. I'm going to scroll down a little bit just to give myself more room. So I have the other possibility that 2x plus 9 equals 0. So I solve by subtracting 9. 2x equals negative 9. So x would equal negative 9 over 2. There's no reason to get a calculator here. Oops, didn't mean to do that. No reason to get a calculator out here. So I know that it's going to be one of those. But 5 can't be 0, so that one's an exception. So I know it needs either be 9 out of 2, negative 9 out of 2, or x equals 2. All right, this one on the right is kind of a doozy, but don't be distracted by how many things there are. We just want to get one side equal to 0. So I have the quadratic term over here, the 8x squared. I'm going to leave that on that side. So I'm going to start moving the other stuff over to the left. So I'm going to subtract 12x. I have 8x squared, 10 minus 12, negative 2x. And then I'm going to add 10 to both sides. So then you'll be left with negative 11 plus 10 is going to be minus 1 equals, and then the right side, all this stuff's going to go away and equal 0. Now again, go through the greatest common factor algorithm. So GCF in this one. Nope. 8, 2, and 1. How about special case? 8's not a perfect squared, so no special. So then I go straight to 3, which is just factor as normal. Now again, we have sort of a trouble spot with 8 because there's lots of factors of 8, but not lucky for us, this has to be 1 and 1, and 1 has to be a plus, 1 has to be a minus to get -1. 1 times -1 has to be the only factorization for -1. So let's just begin by picking something. I'm going to try 8x and 1 just to see if that works. 8x and 1x. So I have 1x in the middle, -8x, and there's finally one that didn't work. So you see that that one is not the correct factorization. And again, I know that the 1 and -1 and the right side of both need to stay there. The 1 and -1 need to stay there to get that -1. So let's try 4x and 2x. 4 times 2 is 8. So I have 2x minus 4x. All right, that one should work. 2 minus 4 is -2, okay? I think that's my correct factorization. Again, by what property? Zero product property. We know that 4x plus 1 has to equal 0, or the 2x minus 1. One of these two factors, since they multiply together to be 0, has to equal 0. 4x equals -1, x equals -1 out of 4, or -0.25, or 2x minus 1 has to equal 0. So 2x has to equal 1, which x equals +1/2. So I have two fraction answers on that one, and that is totally okay. Keep trying here. Now look at this one. Solve the polynomial. 4x to the fourth minus 2x to the third equals 12x squared. Now since I have something bigger than a squared, I know I'm going to have to factor out a greatest common factor. I haven't done anything else ever with something to the third power or something to the fourth power. So once I subtract over that 12x squared, I know I'm going to have to factor out a couple x's here. So minus 12x squared equals 0. Greatest common factor. So I'm going to take an x out for sure. X squared has to come out. What else goes in all these? 2. So 2x squared goes on the outside. I divide all these by 2x squared. I get 2x to the second power minus x. I forgot there's a negative sign there. Right here, -2 divided by 2 is a negative x. And then if I divide this one by positive 2x squared, I get -6 equals 0. Now again, I look for a special case inside of here first. 2 and 6, they're not special, so I'm going to skip that. So I know that I have 2x squared, and I'm just going to have to guess and check or use another method to factor this expression here. So lucky for us, I know that 2x and x are the only possibilities in the first spot to get 2x squared. I can do 3 and 2, or I can maybe do 6 and 1, but I know I have to have a plus and a minus to get that -6. So I'm going to just do the 2 and the 3 here. So I'm going to do, let's do 3 and 2, and let's check. So 2x, -6x, that gets -4x, so that's not the right one. Let's try a different one. Maybe I need to just switch the 3 and the 2 around, so I'll do that. I'll do +3 minus 2, I get 3x minus 4x, and there you have it, -x. I got it on the second try, which is nice. So then I know that by the zero product property, now I have 3 different factors to try, right? I'm trying to change color here. That might have worked. Good. So now I know that there are 3 things I could set equal to 0. I know that 2x squared could equal 0, or I know that the middle term, or middle product, right, 2x plus 3, I should use red. I'm trying to get that red to show up here, but my pen isn't as sensitive. 2x plus 3 equals 0, or the very last one, we know that x minus 2 has to equal 0. That was probably the easiest one to solve. Let's start with the green one. And I know this because of the zero product property. I have 3 factors that multiply together to get 0, so one of these things has to be 0. So in the green factor, you know for sure that x could be 2, or, let's do the red one now. We know in the red zone here that if I subtract 3, why is my pen being so weird? 2x equals -3, so x equals -3 over 2. And finally, we have a third answer this time. And this is where I was talking about where I could have the same answer actually be 2 answers. So if I divide by 2, x squared equals 0. Now technically this is x times x equals 0. So x equals 0, x equals 0. They're both the same answer, but it happens twice. And this is called a double root. And that's when you're solving a quadratic and get the same number. And that's usually 0. So I have 4 different answers. You know what's crazy? What was the degree of the polynomial when I started? I have 4 answers, x to the 4th. It's called a fundamental theorem of algebra. Now, we'll talk about these problems in class.